Okay, I'll first introduce myself. I'm Carl Haas. I'm the chair of the Department of Civil Environmental Engineering, which also has the architectural and geological engineering programs in it, in our department. So it's a large department, and we're really pleased to be associated with the WISE Institute as well. And my personal background is construction engineering and management, and also some technological kind of development. Worked for about 20 years in the U.S., came up here about 14 years ago, partly because I grew up in town here. So that's my background, and I'm not really an expert in buildings or building science. I'm just a moderator, so I'll focus on doing that part. Okay, so I would like to first welcome, and I'll give you a little bit of background about Antoine Habellion. Antoine is a manager of building science department at Rockwool, North America. A main focus of his work, apart from team management, entails managing building enclosure research projects related to energy efficiency, enclosure performance, summer comfort, hydrothermal analysis, building information modeling, durability and resistance. He's a building science professional, and he's got a wide range of clients from engineers to designers. And prior to moving to North America, Antoine worked for Rockwool in Paris, because that's where he's from, France. He did his degrees in France, his master's and his bachelor's degrees. In fact, he went to school in Lille, where I've also had the pleasure of visiting as well. It's a beautiful city. And also he went to school in Paris. And he's worked for several years at Bouygues Construction, which, as you know, is one of the largest construction companies in the world, and I think one of the 2 or 3 biggest in Europe.
Not anymore, I think.
Sorry?
Not anymore, I think.
Not anymore?
Yeah.
Okay.
But close, yeah.
Okay, thanks. So Antoine, welcome Antoine, please.
Thank you, Carl. I'm glad you said I was from France, so people won't be wondering why I sound so funny during my presentation. Okay, so, oops, the other way around. Actually, today I have a very simple message that I would like to present, and I think it's actually a good opportunity here because there are students in the room. And it's a simple message, but I think it's a very important message. We've talked about a lot of very interesting projects today, complex project, passive house, and all kind of net zero building. I actually just want to talk about the very simple buildings, like the typical building, not the fancy. The fancy is good because it's driving, I believe, the industry ahead. But the reality is out there, we have a lot of not very good buildings. And then they're not very good for multiple reasons. By not very good, I mean not very energy efficient, because this is a topic of the day. But we have a lot of existing building as well. And if we actually want to make a better future with, and fight global warming, we need to take care of all these buildings. Just a bit of a context. I'm sure most of you, if not all of you, already know this kind of stuff. But basically, if we don't do anything, we estimate that by 2050, we're going to have a 30% increase in the energy consumption. And we're already today at a stage where over 50% of the carbon emissions are actually driven by energy used in building. But this being said, and this to me is really the key number on this slide, we estimate that the potential for energy saving is 90% if we actually use the technology that we have available today, or if we retrofit existing building, or if we design our building in a better way, meaning not by creating fancy new stuff, just by actually meeting code requirements. And I will come back on this. 90%, that's a lot, just by doing things that we already do, just by paying more attention to how we're doing them. Now, if we look at the commercial and institutional energy use in Canada, just to give a rough idea, 55% of the energy is used for heating, and then we have some energy used for cooling, not as much as we might expect, but like another 5%, and then we have a few other things. But basically, what this suggests is that a lot of the energy used by our building is not like necessarily just from plug loads and occupation. It's just things that we need which are directly related to the building envelopes. And sure, we could decide to heat our building at 19 degrees C instead of 20 degrees or this kind of stuff, but basically just by, this will obviously provide energy saving, but if we just design our building properly, like a more efficient envelope, we could reduce significantly our energy consumption. So now we could argue, okay, well, we're using a lot of energy, so what if we use sustainable energy? What if we use renewable energy? Well, so let's look at this building. It has a lot of solar panels. The architecture is a little interesting. I will let everyone make his own opinion about what he thinks of it, but there is a lot of solar panel here. I'm not sure if these solar panels are only producing energy for the building or if it's making more, if it's a net zero, whatever. Well, actually, I have a way to help you. If we look at the building enclosure of this building, well, we can really see, I'm not even going to touch on the quality of the water-resistive barrier here, which I'm not sure what's happening, but there is definitely no continuous insulation, no exterior insulation on this building, right? So is it what we want to do, put a lot of solar panels? Are we just focusing on renewable energy? Or do we actually want to just use less energy in the first place? I want to remind something, because we've talked a lot today about renewable energy. But okay, renewable energy is renewable and sustainable, but the way that we use to make renewable energy is not always renewable and sustainable. And in this case, for example, if you remember just the previous picture, that's a lot of solar panels, and solar panels are getting better, but they're also using like silicium and stuff that we won't have forever, and they only have a certain lifetime and life expectancy. So we cannot just make renewable energy and be okay with using more and more energy. We actually have to focus on the building envelope. Now, if we look at a typical building, so this is a house. The reason I'm looking at it more like a house, and some will argue it looks like a European house, and it's kind of true, but I think the numbers somewhat are, it's just an idea. It's difficult to look at this for commercial building for one very simple reason. Commercial buildings are very different one from another, from like size and geometry and style and occupation and so on. But if we look just at a random house, we have about 30% and 20% that goes through the roof and through the walls, and then we have another 20% with air leakage. I'm not going to talk about air leakage here, because I don't have time, and this is definitely as important, if not maybe even more important than anything else, in order to reduce the energy consumption, save energy, increase comfort. But just focusing on the building envelope here, obviously there is a lot that can be done with the building envelope. Now, well, when we approach a project, usually what we'll do is we're going to look at, code requirements, and we're going to put insulation in the wall, insulation in the roof. It's very rare that I actually see a customer who wants to really focus on what matters. And what I mean by this is, I think well shown by this picture, is thinking about compactness ratio. Sure, we can meet code requirement just in the roof and in the walls, but sometimes we want to do better, right? But it doesn't necessarily mean a lot to do better everywhere. For example, in these buildings, there's a lot of roofs and not so much walls. So focusing on the roof in this building makes a lot of sense in order to make this building energy efficient. Now, if we're looking at a high-rise building downtown Toronto, focusing really hard on the roof doesn't really matter, except for the guy who lives in the penthouse, who might be the wealthiest guy in the building, but he's really, maybe he has enough money to pay for higher energy bills. But what really matters on these buildings will be the walls, right? So focusing on what we actually need to make. What do we need to make to design in a better way? So now about this, let's talk about thermal bridging. I'm sure most of us already know what a thermal bridge is, but I need to make sure we're on the same page here to introduce the next thing. So thermal bridging basically is when we have a material with a higher conductivity going through a material with a lower conductivity. There is a pretty interesting picture here. This is a wall. I don't want to say typical just because of how much steel studs there is in this thing, but there is a wall made with steel studs and with batt insulation, right? Most people here, probably not in this room, because based on the discussion we have been having today, definitely we're people who've been focusing on designing better buildings. But again, the reality out there is that most people, they'll go to the store or they will design a building with, and they will put insulation in the wall. But what they're going to do is they're going to put insulation between steel studs. Wood studs will be the same logic, not as bad, but they're going to say, hey, I'm designing my wall, it's R19, it's R20. But really, when they're putting insulation in this wall that has so many steel studs that it looks like the contractor tried to get rid of the extra steel stud or something, when he's putting the insulation between these steel studs, are we really getting R19? Obviously not. I don't know. Maybe we're getting R5. Maybe not even. So we're actually not using the material efficiently. And obviously, we kind of like steel studs, right? It's not like we don't have many steel studs in our buildings. So we're saying, hey, we need more insulation. And today the topic is innovation. And one question I get very often from people I meet is, what is the innovation in the insulation world? Are we going to make like a thinner material with a higher R value? I mean, sure, it would be great to be able to do this. And there is actually innovative materials. But the first thing we really need to question ourselves, in my opinion, is how we use our insulation. How actually efficient the use of our, how the efficient use we made of our insulation. When we put insulation between this, we're not using it efficiently. And that's what most buildings do. Continuous insulation is becoming a thing for sure in Canada, but we still see a lot of residential buildings with just either nothing or like 1 inch on the exterior, and everything is really in the cavity, and we consider this to be a good new building. No wonder why, I don't remember who showed the slide earlier, like the newer building were actually performing not that much better than the older buildings from the 90s, because we're putting more insulation, but we're not using it in an efficient way. Also, here's the detail around the metal structure. It's going to be complicated. So this is something we have to think about during the design phase, right? And when I say we like our steel studs, we really like our steel studs, right? We really like thermal bridging, and this is not special. This is just the typical average building. So sure, we can push for better energy codes and passive house and all this, but this is a small little piece of people who are willing to make buildings better. But most buildings are going to be built like this, which is okay, but they're going to put most of the insulation between this. So now we could argue, okay, maybe there is better systems. So this is an example of thermally broken studs. They're structural studs and they're thermally broken. Is it really the way we want to go? Well, I mean, sure, we can do this, but this is probably not the solution for like everyone, right? And so we really need to better use our insulation. We need to focus on continuous insulation. So I'm sure some of you are thinking here, well, that's what we're doing, right? That's what code is doing. Code is pushing for more and more continuous insulation. And that's true. And if we look at the Canadian Building Code, or if we look at the code in Ontario, like here, for sure, the continuous insulation requirements are increasing. The problem is, we're putting continuous insulation because we want to better use our insulation that we're putting between studs, but it's almost like we're creating a new layer of studs on the exterior because we use Z-girts then to install insulation, right? We put insulation between Z-girts and to attach our cladding. So Z-girts, typically they will be horizontal, installed at 24 inches on center, what the type of impact they have on the insulation effectiveness is about 50%. Obviously, it's going to depend again on spacing and orientation of the girts and so on. But again, we're putting insulation and we're downgrading the actual effectiveness of the insulation by about 50%, and it could get worse. Sometimes, not very often, which is a good thing, but sometimes, you can see vertical Z-girts, which are going to be perfectly aligned with steel studs. So the reduction there on the actual effectiveness of your insulation is not 50%. It'll be 60%, 70%. So we're pushing for more insulation, but we're also pushing for more thermal bridging. So we really need, in my opinion, to question ourselves, okay, well, we have all these better codes, and we keep pushing for more and more insulation. But I think the question is really how we use it, how we design our building. Now, if we look at the definition of continuous insulation in the code, it's actually pretty interesting. So the definition said it's insulation that is uncompressed and continuous across all structural members without thermal bridges other than fasteners and service openings. That's actually the definition. So it's interesting to see that we have a definition that is pretty simple and straightforward, but somehow this is not really the definition we're following, right? So we have systems out there. This is an example. There's many other systems, things called like thermally broken clips. I'm already at 15? Oh, wow, okay, I'm almost done anyway. So we have like better systems that are way more efficient, and there's many, many systems available out there. So it's not necessarily innovation that we need. These systems that already exist, some of them are actually pre-owned, and there's a lot of options, and there's a lot of good options out there. There is even more efficient systems. We know how to actually install installation in a very effective way. And one thing I will say, and this is the last thing I will say, by using our installation in a more effective way, we might actually be able to reach a higher performance with less, which means we might actually be able to make the overall thing less expensive. So when we say that making building very efficient is good but costs money, it's actually not always true. It's actually just require more thinking. And in order to use more thinking is to definitely use integrated design process, which a lot of us have already talked about today. So I will finish here. Thank you.
Thank you. Thanks. Well done. Thanks to Antoine, and I'm wondering if you all would mind if we waited to have questions until the end. Is that okay? Okay, thanks. We'll bring up our next speaker then. And our next speaker is Andy Oding. Andy is the General Manager and Senior Building Science Associate, Building Knowledge Canada. He's got an extensive background as a builder for over 20 years, and he brings a lot of practicality and building science principles to field applications. And he's a recognized building science trainer by the Government of Canada Office of Energy Efficiency, building science specialist with background at University of Toronto, HVAC designer, and he's working closely with the development of the new National Building Code of Canada, Standing Committee on Energy Efficiency in Housing and Building, the redevelopment of the ASHRAE 90.2, and some related codes. And welcome, Andy, and looking forward to your presentation. Thanks.
Thanks, Carl. Good. Okay, so I'm going to try to move pretty quick here because we have sort of limited time. So I'm going to put my Canadian home builders hat on today. So as former chair of the NetZero Council of Canada, which is one of the largest industry associations in Canada outside of the oil industry, and many of the builder members are here today, but also as chair of the Technical Research Council, I'm going to walk you through some of the lessons learned by the home building community. So I want you all for a minute to stop thinking about tall towers that we've heard about and really complex mechanical systems. Ted Kessick down at U of T would say the reason you have tall, complex mechanical systems is because of irrational envelope. So if you want to rationalize the mechanicals, rationalize the envelope. Little hint to you guys in commercial. So we're going to talk about residential real quick. So here's what we're going to talk about. We're going to talk about codes. We're going to talk about where it's going. We're going to talk about what the home builders in Canada have found out, because they have probably one of the richest histories in low carbon, net zero energy type homes, even back from the R2000 days. We get all sort of psyched up about these things called passive house, and the reality is that passive house, those dear Germans over in zones 3 and 4, got all their technology and information from Canadians. So don't sell yourself short. All right, so we have the Pan-Canadian framework. There is one note in here I want you to make note of, one word in here, and it is the bottom word, and it is the word existing. So we can talk all day that we want about new homes and new buildings, but quite frankly, folks, the biggest work that our building codes have in front of us is the existing stock in the homes and buildings that we live in today. This is where the building code is proposed to go. By the year 2032, as we'll be living in net zero ready type homes. You think this is something of the future, something of sort of a Tesla-like. I'm going to have two gentlemen in the room stand up right now, Sean Marsh and David Bricks. David from TerraView, president of TerraView, Sean Marsh, president of Timberworks Homes. These gentlemen are building 2032 homes, net zero homes, not just single homes, but communities of net zero homes in your community. This is not something we have to wait to see because it's happening today. So kudos to those gentlemen. This is the British Columbia Step Code. This gives you an idea. You've already seen mass of it. On the housing side, the Part 9 side, what basically happens is you have 5 levels. Every 5 years, one level is going to disappear, and pretty soon we're going to be at passive house or net zero home levels. That's where we're headed today, and if you want to build a house in North Vancouver today, you have to hit Tier 5. This is the Ontario Building Code, and I want you to notice the little sign up in the corner that tells you that the new homes built to today's code in Ontario are 50% more efficient. Back in my days of framing, we are doing houses very different from the time we started to construct homes till to now. Can you think about how efficient your automobile would be today if the auto manufacturers had done this in their industry? You wouldn't be driving internal combustion cars. This is the Building Code of Ontario. Back in the 2012, we had energy brought in the building code. 2017, last year, we jumped by 15%. The idea is that by the time we get to 2030 to 2032, the minimum code, building code, again, is what you build, and you build to this level so you don't go to jail, okay? So this is the minimum. This is what we're going to have to be building by that time, and this is where the builders are headed. Keep in mind, you already have builders here in Ontario that are doing that. In the US, we have the same situation that's occurring. As they get closer and closer to zero on their energy scale in the residential, they're getting closer and closer to their net zero level here. Now, here's the fascinating thing. We think that politics is going to drive so many of these decisions, but I will tell you that 22 states in the US have adopted the 2012 or the 2015 IECC or thereabouts. And what's happening is in those states, it's mandatory to get a blower door test before you can occupy a house. That's pretty cool. My home state of Michigan, they were a red state. You folks know what that meant last year in the election? All right, get some chuckles. Here's what it meant. Yes, they voted for the guy in red. However, last year, the state of Michigan, as a red state, adopted the 2015 IECC, the most stringent energy efficiency code in the history of the U.S. to date. Why'd they do it? It wasn't really because they were worried about carbon. It was because they were worried about what all consumers are worried about, and the fact that your energy bills keep increasing every year. So if you think that politics is the driving force behind energy codes, you have another thing coming. It's the consumer that's going to drive this. When you look at the history in Canada, and far as net zero and low carbon homes, we have a long history of it. Back from the equilibrium days, all the far back as the R2000 homes and the homes that Andy Goy is going to talk about. We had communities. Madame was here today with Subi talking about a net zero community they built out there in Alberta. Next door, you had Reed's Heritage Homes doing a community. You had Minto down in Ottawa. They learned lots of lessons. Here's some of the lessons learned. What 20 years ago took us $150,000 to do now costs us $40,000 to $50,000. That's pretty cool. And to be net zero ready, the house, the same house as a net zero home, but without the renewables on, you're talking 10 to 12. Now, that does add cost, but what it means is that the builder industry is innovating. There's still lots of room for innovation. I'll let Andy talk about these projects across Canada. We'll share these slides. You can look at them. This is one of the projects that was done in the Guelph area. Up until recently, you could actually tour the home. And again, these were homes built to the new Canadian Home Builders Net Zero Ready or Net Zero Standard. Again, all which is built off the R2000, the Energy Star program, and is now being built to across Canada. If you want to know the simple envelope solution, if you have attention deficit disorder like I do and you want somebody to tell you, just tell me how I got to build my house to get to net zero ready or what's going to meet 2032, here you go. These are effective R values. R60 up top, R25 in the wall, R25 down below. What's an R6 window? Triple glaze, air tightness of 1.5, right size mechanicals, and there you have it. Now, let's talk about energy in homes, which you have to understand the context of where we've come from, where we're going. These are the homes that we used to live in. And here's what this house did. It developed about 19 to 22 tons of greenhouse gas. It used about 200 gigajoules of energy a year. Gas or electricity or wood or propane or oil, whatever you had. Here's the big deal. 75% was space heating. Where was air conditioning? It didn't exist. That was in your neighbor's house down the street where you went to cool off. Here's that same home today. Your largest load is space heating. Here's the thing you have to be careful about driving low carbon and low energy building codes. You might drive to low energy and get this big space heating taken care of, but I'll ask you, those of you that actually live in houses, what do you pay more for? The large heating or the little bit of space cooling? Space cooling. Why? It's electricity. So be very, very careful thinking that our immediate future is all electricity. We believe in air source heat pumps. We believe in geothermal. But if you took all new built homes today and made them have the most efficient geothermal systems on the planet Earth, their utility bills would still be higher than using a right-sized natural gas furnace. So be very, very careful about that. If you look at a net zero household, so the builders at the back of the room, here's what their profile looks at. What's the biggest energy use? Raise your hand. You, okay? These net zero homes that they're building to 23 standards, the entire house runs off from 1/3 of the solar panels. The rest of it are your beer fridges. It's your Xboxes. It's your gaming systems, things that the builder has very little control over. So where does the opportunity lie? Behavior control. We were net zero in our house 3 years ago until we put a hot tub in the backyard, so we learned our lesson. Here's the thing I want you to understand about this house. This is a house that uses dual fuel. It's electric air source heat pump, well insulated, it's airtight, it's got great windows, but it uses a little bit of electricity and a little bit of gas together. And here's what happens. We're not at 22 tons of greenhouse gas. We are now down to 1 to 2. Wow. Now, at some point, we'll be able to go to zero, but we are moving along. So here's the thing, though. This is all great. It's wonderful. And here's the thing. You're lucky to have people like John Straub and some of the other professors with you. Because here's the thing. I remember as a day growing up in the U.S. with a mom and dad who are a graphic artist, an architect, an interior designer, and my memory of going into efficient homes built out of the energy crisis back in the 1970s was they smelled bad and they felt horrible. That was because we didn't use building science. And here's the thing, be very careful of trying to make things very efficient or low carbon without thinking about the durability, like we've heard about today, or the impact on occupants. Do you know, actually, there's been quantified studies done that if you build a house to make it perfectly comfortable, let's take ASHRAE 55, good insulated walls, good windows, mechanicals that move the air, the right airspeed, everything else, you basically arrive at the same house as a net zero low energy home. That's pretty cool. So if you build for the occupant, as Dr. Robert Bean would say, build the house for the occupant, the building efficiency is going to follow. So where do we start in these homes with today's building code here in Canada and in Ontario? Well, we would look at this and we go, okay, let's take the biggest one, heating. Well, here's what makes up the heating. So this tells you where the technologies need to start and where the builders are headed. The largest one is, it's not the roof. We keep asking the normal people and yourselves, where do we add insulation? Well, let's put some more up in the attic. No. We need better windows. We need air tightness. We need technologies. Now, I'm going to make you take a step back. How many of you have heard of the minimum innovation threshold? How many of you read books like Built to Last and Good to Great? Okay. They talked about the top performing companies in the history of the US and Canada, and that each of these companies had a minimum innovation threshold. They weren't exactly new adopters or the first adopters, but they innovated to a minimum threshold. And I will tell you that here's some things that as a construction industry and as designers and architects, we are going to have to be involved with if we're going to survive and meet the innovation threshold. The first one is you've got to understand the building science tipping point. As houses become more tight, more insulated, our comfort risks go up, and so do a number of other things. This was a statement put together by Sam Rashkin, who is the chief architect for the Department of Energy. Sam learned everything he knew about building science from Canadians. I think he'd be okay with me saying that. And here's the thing. This type of stuff here, and you're learning about from John and the U of W staff, is we will have more problems with this if we keep putting insulation in walls and making houses and buildings airtight and we don't manage the water. It all goes together. As a master builder building cathedrals in Europe years ago, you spent years and years understanding how to manage the water. So, the other thing too, minimum innovation threshold, understand the consumer and don't assume you know them. This is a largest consumer survey of Canadian households in Canada. It's been done for 15 years. This year, this was a survey that was done of people that were going to buy homes in the next 10 months. They were given a list of 120 items and asked to choose what on this list do you feel has to be in your home. Not if I had the money I would buy it, if I had to be in the house. This is pretty interesting stuff. Our consumers are changing. We heard they're not asking for it, and quite frankly, I'll tell you my experience as a builder and secret shopping the builder salespeople, the reason that people aren't asking for it is because they don't know to ask for it until it's put in front of them. Once they know the impact of it, then they start to ask. I'm going to go through this pretty quick. Just some things that you need to have on your list. Number one is you need to make sure you have your water management details. Don't start even moving forward the net zero enclosures until you tighten up the water management. Better windows. We need good windows beyond triples. We need smart heat recovery, moving from HRVs to ERVs. We need efficient fans. We've got smaller loads. You're eventually going to have to start to look at renewables and battery storage long before you get to zero energy, because our grid is old and we cannot use it as a battery. We have to have buffering capacity. The other thing, too, is forget new buildings and new homes. This is the biggest fish to fry. We need something that stands behind a nutrition label on existing homes. The minute you start to help us as consumers understand how our home operates or how the home we're about to buy operates, our thinking starts to change. And yet we're so afraid of it. The Real Estate Association is afraid of this. They're afraid it's going to hurt sales. Well, guess what, folks? It's no different than really what we have today. It's just better. We could always tell what the energy use is in a house. How do we know that? You ask for the utility bills. Okay? This just tells you what you can actually do to make the house work better. The other thing, too, to be careful of with the all-electric economy, I'll leave the study for you, is if we go all-electric immediately, we actually run the risk in several provinces of actually jacking up our carbon production. So again, we have to have a long-term game plan here. And in some provinces, we actually run the risk of, yeah, we could do it, but it's going to cost the homeowner significantly more to live in those homes. Mechanical systems, we need smart systems, we need small systems, and we need very small systems because the loads in these homes are very, very small. The domestic hot water load in a net zero home is the same, if not higher, than the space heating load. So forget about the furnaces, let's start concentrating on some of these other items. The other thing, too, that we're seeing is that the car and the home will become one. The pictures you're seeing here are actually Toyota. They build about 3,000 to 4,000 homes a year, they modularize them, and now they've bought 4 of the largest home builders in the US. Of the larger home builders, I should say. They've invested in their companies. Interesting, isn't it? Guess what the backup power source is for this house? It's your plug-in Prius. You want to know what's happening on the Canadian side? Look up this gentleman, Reza Nassari. Reza was one of the only builders in the history of Canada to be given the Order of Canada Award just this last year. They build about 500 to 600 homes a year out of Edmonton and Calgary. They now build homes for 5 of their competitors. They now build net zero as a standard in some of their communities, and the starting price for a full net zero, single detached, 1,700 square foot home is $399, all in. That's zone 7. It's cold. He's also doing this through lean manufacturing. You can eat off the floor in the plant when he's done. You can go online and look at the company. Any of you interested in investing, the one thing Reza says is the place that they like to go is where the lean manufacturing base exists. Guess what? Cambridge, Ontario is a wonderful spot. The other thing to understand is that down here in London, we have one of the largest net zero communities already in place and being built. Sifton is building a community called W5. It's an all net zero community. Some of the challenges they had was they had to become a microgrid because the utility didn't know how to deal with them. So they actually had to partner with them to make sure it survives. So again, partnerships versus the utility being a barrier. Storage is going to be very important beyond generation. One of the last things I'm going to leave you with is here. We have to have affordability. These homes will cost some more, a little bit more, but the one thing we do not have in Canada that they quite frankly do have figured out south of the border and some other places are mortgages and appraisal process that take into account the operating cost of the home and the building. When we start to understand that and have an appraisal and a real estate profession that understands this, it's a game changer for the builders, for the technology, and for the industry. Thank you.
Andy, that was like drinking from a fire hose. That was great. Thanks. Yeah, yeah, excellent. Two really stimulating presentations so far, and really good at staying on schedule. Thanks. So we'd like to welcome another Andy next, Andy Goida. Andy is a Canadian builder lead and market development manager, Owens Corning, Canada, and he's been actively involved in the industry for over 35 years and has done pioneering work around establishment of Energy Star for new homes. Served on the CHBA Board of Directors for 10 years, served 2 terms on their executive board, and he's currently a board member of EnerQuality and sits on the CHBA Net Zero Energy Homes Council. He has a number of their highest awards. He's a past recipient of their Riley Brethor Award, and he's also earned an induction into the OHBA EnerQuality Hall of Fame. So we'd like to welcome Andy, and I'm sure we're going to learn a lot from Andy as well. Thanks, Andy.
Thank you. I can assure you one thing, that I can't talk as fast as Andy does, but I will condense the presentation so that we do have time. There we go. I'm going to talk to you about the Eco Energy Innovation Initiative that we were part of. And this was driven by NRCan, and we were asked to the table because of the work we were doing with builders. We were tweaking the way they were constructing homes and being able to pull out cost to make them affordable, right? And we did that through the air barrier system. We've heard from previous speakers now that air tightness is critical in all of this, right? So we need to work at getting air tightness down to 1.5 air changes or below. If you can do it with the continuous insulation, right, that's required when you're building net zero homes, think of this. You are addressing air tightness, heat flow, airflow, and the product is a weather barrier as well. So now you've addressed the 4 elements in one application, and now you can take a look at pulling costs out to keep those homes affordable. At the time we started this project with Enercan, this was the only system that had CCMC evaluation report confirming that it's a systems approach. Today, there are other systems on the market that'll do the same thing. And going forward, you're going to see more because air barriers are moving from inside to outside. The goal of the project was to make net zero homes production friendly, all right, and the community's production friendly. So we took an opportunity to work with some of the key builders throughout Canada, and the background of the project was that Natural Resources Canada introduced this project. The ECO EII program was searching for long-term solutions to eliminate air pollutants and greenhouse gas emissions, and there were 2 programs involved. One was an R&D, and the other one was a demonstration project. Ours was a demonstration project. The Enercan kicked in 50% of the total cost over those 5 years, and the participants had to come up with the other 50% with in-kind contributions, right? So, and that wasn't an issue. All the builders that we talked to didn't hesitate for a minute in terms of being part of this. So it was Natural Resources Canada and Owens Corning. We had 5 production builders right across Canada. We had 5 regional consultants that participated as well. So each builder was paired with a consultant. And there were also industry partners because we couldn't do this on our own, right? The intent was to build, or the purpose was to build 5 net zero housing communities with a minimum of 5 net zero homes per community, right? And to ensure that they were affordable as well. And the way we did that was using off-the-shelf technology. So not going crazy with new stuff, but just taking the things that we were good at and tweaking them to make them better, to keep the costs down. So the builders were Mattamy Homes in Calgary, Reed's Heritage Homes in Guelph, Minto in Ottawa, Construction Voyer in Laval, Quebec, and we worked with Provident Homes in Bedford, Nova Scotia. So this project, this 5-year project, was completed at the end of, was completed mid-2016, and it demonstrated the feasibility of building net zero homes. It also addressed the challenges, which I'll be talking about in the next couple of minutes. Addressed the challenges of building net zero energy homes, and we've heard of some of those, and acted as a platform to broaden the adoption of net zero homes. And you know what? That's exactly what has happened. We've got the development of the CHBA Net Zero Council now. Members from right across Canada, builders right across Canada are members of that council. We have manufacturers as part of the council, consultants as part of the council, so everybody is working together to make this happen. Andy touched bases on the R2000 program, how everybody else has adopted it as well. Well, this was the platform for the Net Zero project, was the R2000 specifications, and then we added to it to get the Net Zero ready. And as Andy has mentioned, others have bordered with. Build America was based on the R2000 program. The Net Zero Home, based on the R2000 requirements, right? So we, as Canadians, are leading this. And then each home on this program was labeled with the new energy rating system that Andy had talked about as well. Industry partners, these are the partners that stepped up, and just the same as the builders, when we talked to each of the builders, they didn't hesitate to sign up for this, knowing that it was going to cost them to do this. These partners stepped up to the plate as well, right? So they were part of the whole program. Before the builders even broke ground, what we did was we held charrettes, design charrettes, and we had the 5 builder groups in the room, we had their designers in the room, We had Natural Resources Canada there. We had the Canadian Home Builders Association there as well. And everybody was working through these design charrettes, sharing best practices, what will work, what won't work, right? And what came out very clear, and you've heard this already through other presentations, is that the most cost-effective way to build net zero homes is to conserve energy first, then generate what's needed. So it's the envelope that's key to all of this. You get a super tight and super insulated envelope, and I'm not talking envelopes that are 4 feet wide. We're talking traditional construction moving from 16 to 24 inches on center, increased R value in the cavity, increased continuous insulation on the outside, and using that continuous insulation as the air barrier. And that allows you to pull up costs, and then you take a look at what you need to generate. And as Andy had mentioned, we're going to be there. It's not a question of if, it's when. And it's going to be by 2030 or by 2032. We will be at net zero ready. These are the design specs that the builders used in terms of their net zero homes. And I'll tell you, over the project period, this didn't change very much. This pretty well stayed the same. Take a look at the bottom line in red, the air tightness target. So everybody came in below 1.5 air changes, right? And those that are building net zero ready home, like the two builders in this room, are coming in at levels lower than that as well, right? So it's important. Air tightness is the key to go with this. Now, let's take a look at some of the homes. Mattamy Homes in Calgary. This is the type of home that they built on the program, right? Reed's Heritage Homes. You've seen this on Andy's slide, right? When you drive by these homes, they don't look any different than a co-built home, other than this home generates its own energy on an annual basis, right? What we did with every builder to get the word out to potential buyers, to existing homeowners, and to the industry, we held events around all of this as well, right, in terms of media coverage when they were breaking ground, and also at the ribbon cutting as well. And after the ribbon cutting ceremonies, these builders had sessions in the home educating potential buyers on what the value is of net zero ready homes. Minto in Ottawa, their first net zero energy home was a single detached home, and then from there they went on to towns, or blocks of towns, and got them to net zero energy. And again, ribbon cutting ceremonies, press releases, and homeowner seminars held in each of the homes as well. Construction Voyer in Quebec, right? This is a picture of their project at the framing stage that was being air tested. Right? So no insulation, poly, or drywall in the walls. The air tested to 1.5 air changes actually at this level, right? And then they got even lower during the construction period. And Provident Homes in Bedford, Nova Scotia, again. I mean, the homes look like they're traditional homes. There's nothing different about these homes other than they produce their own energy on an annual basis. Here's what we learned, and this holds true today. First of all, when you start with this, you need to get everybody involved. Anybody that touches this home has to know what's going on. So we're talking regulatory and we're talking community barriers as well. You need to have everybody in the room at the same time so that everybody is on the same page. Trade resistance. Whew, and we saw a little of this. And I'll tell you, they need to learn. You need to train and train and train the trades. Dunshire Developments is starting their net zero development in Caledon. And what we did was we had the trades come in to their office and we had a classroom session. We explained to every one of them why things are changing, why they have to do things a little differently, right? And the reasoning for that. Right? And then before they started construction on site, we were on site. Actually, this Monday, we were on site again with the framing contractors to make sure that everything was going in that direction. The issue is trades, that there aren't enough skilled trades in the industry. That's why you're getting builders looking at panelizing or modular building. And I'll tell you, that is going to take off over the next few years. You're going to see more builders panelizing. You're going to see more of this stuff done in-house and then shipped to the site and erected in process. Optimizing popular house designs for simplicity and for comfort. You know, the more complicated the home is, the more it's going to cost to get to net zero, to net zero ready, or net zero, and the costs are going to go through the roof. So you have to take a look at those things and optimizing. Achieving air tightness, again, man, without this, nothing happens. Doesn't matter how much insulation you use, doesn't matter what kind of mechanicals you use. If the home isn't airtight, it's not going anywhere, so you have to do that. Affordability, again, right? It's great to build net zero homes, but if they're costing you $100,000 over and above to build, who's going to be able to afford those? So you got to keep those costs down. And the way you do that is by tweaking what you're currently doing, right? So yeah, moving the air barrier to the outside using continuous insulation, for example, is going to cost you more, right? But from a total cost perspective, when you start pulling costs out that you don't have to do anymore, then it all of a sudden makes sense and affordability is back. And marketing. And Andy and I actually just came back from the CHB Net Zero Council strategy session. This was one of the key things that came out of that strategy session is how do we sell this to the homeowners? You know, it isn't the fact that technology isn't there to build them. Current technology is here, and we can build them, and we can build them cost effectively. But how do you sell through the value of this? Right? Selling energy efficiency now may have worked 10 years ago, but you now got to take it to the next level. You got to sell through the value of what net zero brings to the table, like the comfort, the health, the quietness, the improved indoor air quality. Those are the things that you got to ratchet up now. And oh yeah, by the way, it is energy efficient to the point that it produces its own energy on an annual basis. Right? So you got to start promoting the comfort side of things as well, right, with the program. So if it wasn't for these people listed up here, this is what brought net zero from the back burner to the front burner. And it's the way of the future, and we've got builders now building net zero homes. I'm working with 3 other builders who are doing the same, that are going to be building net zero homes. Reed Heritage Homes in Guelph, for example, is building their infill site that's now going net zero homes. So it was because of these builders, right, and because of the consultants and the other partners that came to the table to help drive this. And I want to leave you with some information that's exciting to me. And this revolves around Owens Corning. This is what Owens Corning is doing in the US. And what we want to do is we're exploring to do this in Canada as well, very cost effectively. So as of November 2017, our EcoTouch insulation, our unbonded loose fill insulation, and our thermofiber insulation is being produced with renewable energy. And these are the labels that are appearing on the packaging. And the most exciting thing about all of this is others are following suit. Just think, by 2030, if all those net zero ready homes were insulated with insulation that was produced with renewable energy, how sweet would that be? That'd be cool. So we're working at doing that in Canada as well. Thank you very much.